we're asked to use the method of Lagrange multipliers to find the points that represent the absolute extrema for f of x comma y subject to the constraint x squared plus y squared equals 81. To use the method of Lagrange multipliers, we need to solve the system of equations shown here below involving the partial derivatives as well as the constraint in the form of g of x comma y equals 0. So we have f of x comma y, but we need to write the constraint x squared plus y squared equals 81 in the form of g of x comma y. To do this, we need to set one side of the equation equal to 0. Let's go ahead and subtract 81 on both sides, which gives us g of x comma y equals x squared plus y squared minus 81. And now let's work on setting up the first equation given by the partial of f with respect to x equals lambda times the partial of g with respect to x. So for the partial of f with respect to x, we differentiate f with respect to x, treating y as a constant, which gives us negative 2x plus 5 equals lambda times the partial of g with respect to x, which is equal to 2x. For the second equation, we have the partial of f with respect to y equals lambda times the partial of g with respect to y. For the partial of f with respect to y, we differentiate with respect to y, treating x as a constant, which gives us negative 2y plus 5 equals lambda times the partial of g with respect to y, which is 2y. And our third equation is g of x comma y equals 0, which is x squared plus y squared minus 81 equals 0. And now to begin to solve the system of equations, we will solve the first equation for x and the second equation for y. To solve the first equation for x, we need to get the terms with the factor of x on the same side. Let's go ahead and add 2x to both sides and also change the order of the equation. Let's write the equation as 2x lambda plus 2x equals 5. Next, factor out 2x, leaving us with 2x times the quantity lambda plus 1 equals 5. Next, we divide both sides of the equation by lambda plus 1. Simplifying, we have 2x equals 5 divided by the quantity lambda plus 1. Instead of dividing both sides by 2, let's multiply both sides by 1/2. Simplifying, we have x equals, let's write the right side as 5 divided by the quantity 2 lambda plus 2. And now we need to solve the second equation for y, and we'll follow the same procedure. We will add 2y to both sides and change the order of the equation. We have 2y lambda plus 2y equals 5. Factor out 2y. Divide both sides by lambda plus 1, which gives us 2y equals 5 divided by the quantity lambda plus 1. And once again, to solve for y, we will multiply both sides by 1/2. Simplifying, we have y equals 5 divided by the quantity, again, 2 lambda plus 2. So what's special about this is notice how both x and y are equal to 5 divided by the quantity 2 lambda plus 2. So the important thing that we just discovered for these first two equations is we now know x is equal to y. Knowing this, we can now substitute x for y or y for x in the third equation and then solve for the single variable. Let's go ahead and substitute x for y. Performing the substitution gives us x squared plus x squared. Let's also add 81 to both sides, equals 81. Combining like terms, we have 2x squared equals 81. Divide both sides by 2. Simplifying, we have x squared is equal to 81/2. Take the square root of both sides. We are going to have a plus or minus value for x. We now know x is equal to plus or minus. The square root of 81 is 9, and we have the square root of 2 in the denominator. And remember, x is equal to y, so we also know y is equal to plus or minus 9 square root 2. So we have 2 points to consider. One point where both x and y are positive 9 divided by square root 2. and a second point where both x and y are negative. And now to find the z-coordinates, we need to evaluate the function f of x comma y. And if I had done this to save some time, notice when both x and y are positive, the function value is approximately negative 21.3604. And when both x and y are negative, the function value is approximately negative 148.6396. So the largest function value represents the absolute maximum. The least function value represents the absolute minimum. So the absolute minimum is approximately negative 148.6396. The location is often given using the x and y coordinates. And the greatest function value, or z-coordinate, is the absolute max. The absolute max is approximately negative 21.3604. And the location is often given using the x and y coordinates. So it just depends on the question. You may be asked to give the ordered triples. You may be asked to give the absolute max and min and their locations. Before we go, let's verify this graphically. The graph of f of x comma y is the graph of the green surface. This blue space curve is where the constraint intersects the surface. Notice how this red point here is the highest point that is on the surface and satisfies the constraint. This point represents the absolute max that we found. And this low point is the lowest point that also satisfies the constraint and is on the surface. This point represents the absolute minimum. So this graph does verify that our work is correct. I hope you found this helpful.